Everyone. I don't know if you remember me. I am Aryan. Okay, back again here, right? Today's lecture that we call the Going Forward lecture. So, what is it about? We have invited four IITB students who we believe to have, you know, done enough in some certain application of Python. Okay, so we have people from quantum computing, we have people from web development, from astrophysics and machine learning. Okay, these people will go over how Python was useful to them in their projects and ventures, and they'll just go over their fields and they'll, help you get acquainted. Yeah, and this is the final lecture. We will be having a safe quiz. Okay, so please pay attention, sort of, I guess. Uh, we'll be posting about the safe quiz soon in the middle. Yeah, and so let's begin with the final lecture of PyCK 2021. Okay, so I'd like to invite Sagar. Uh, he is a student in EP. He's in his fourth year. So, Sagar, uh, I
Yeah,
would
hi.
really like you to start. Yeah. Hey,
Uh,
so can you share your screen?
yeah. Is my screen visible?
Yes, it is.
Okay. So, hi, I'm Sagar, fourth year engineering physics student. So, you can contact me here. This is my mail ID. Um, so, my main focus uh, in my studies has been on astrophysics. Whatever projects I have done until now have remotely or directly been connected to astrophysics, and in particular, all my most of my work has been in gravitational wave astrophysics. Right. So I'll just quickly go over what the astrophysics field is about. So basically, astrophysics answers three questions, or attempts to answer three questions. How does our universe work? How did we get here? And are we alone? So uh, how does the universe work as in the physics of bodies, multi-body systems, nebulae, and other sorts of objects all around the universe? How did we get here is the evolution of the universe, and are we alone? So you would know the exoplanets that NASA usually detects and just turns out, okay, life might be possible here, right? And astrophysics has two sibling sciences, so astronomy and cosmology. So these are very similar, and the difference or the borderline between all these studies is very uh, not very clear, right? So I'll go over how what astronomy is, right? So astronomy is study of celestial objects and phenomena. Okay. Uh, Right. So as you can see here, one of the aspect is the study of celestial objects and phenomena. Right. Celestial objects include planets, stars, asteroids, comets, nebulae, black holes, everything else. Related phenomena are supernovae, quasars, pulsars, etc., etc. Right. Lots of things. And again, astronomy is classified into two, observational and theoretical. So observational is basically you going out with a camera in a clear sky and just recording whatever you're saying, right, with your camera, and then just processing it. Okay, right. Theoretical aspect is theorizing so the first record of anyone theorizing how the celestial objects work was Newton, the theory of gravity, right? Newton's theory of gravity, and then Kepler came, and everything happened, and then finally we have the most evolved theory which we have right now, which we can say works, is Einstein's theory of general theory of relativity, right? Uh, so the image you see here is taken. So reference is here. Slides will be uploaded, and you can just go here and check. So the astronomy picture of the day is a website that NASA regularly updates, regularly as in per every day, and there you'll find every day new images popping up. Right? So this is the image of a nova, right? It's not supernova, kilonova, anything. Just simple novas. Novas are what caused by white dwarf stars accreting mass from another star. So this nova recently became visible to the naked eye, and I think it's going to become visible again in 2 to 3 days. So I mean, if you're curious, you can just go out and look at it. Right. This is the okay again lobster claw nebula, bubble nebula are not really useful. Right. Cosmology, which is the other sibling of astrophysics. It deals with the origin and evolution of the universe as a whole, right? Where did we come from? So from Big Bang to where would we end, which is theorized as the Big Crunch, and the expansion of the universe, which we know that the universe is continuously expanding, and that is one of the things which helps us determining the distance an object is from us. So you would always hear people talking in terms of not in terms of megaparsecs or gigaparsecs or what kilometers or anything, but you would often find people talking in terms of redshifts, which doesn't make sense if you're not from an astrophysics background, but you know what redshifts are. So velocity is sort of in a cosmological point of view directly related to how far away the object is from you, right? So again, there are various different models which describe how the universe expands or is evolving now. Okay, so my main focus in my studies has been in gravitational wave astronomy. Right. Well, I'll just quickly go over what a gravitational wave is and blah blah blah. Right. So just imagine you have a sheet of cloth and you just drop two balls, right, and watch them evolve. So now when the two balls are just going around each other, they're gonna make ripples on the sheet, right? Now just imagine that sheet is not a two-dimensional thing, but a four-dimensional thing, which is space-time, right? Now these two heavy objects, they can be anything, but the ripples which are being produced in your sheet are called gravitational waves in 4 dimensions, right? So in the three figures you see here are two neutron stars going around each other, eventually losing energy. So you would think that two objects going around each other are conserving energy, but they lose energy with gravitational waves and eventually come together, come close and just merge into one single object, right? How does the data look like? So again, you are recording the gravitational waves, which again will be a whole new topic of discussion of how the gravitational waves are recorded. But this is what the data looks like, gravitational wave data. And this, so what essentially you do with, you can do it with any sort of programming language, but what essentially you do is you fit whatever your model you have into the data that you are getting from a detector, and then see with what probability can you say that whatever you have say is a signal or just a background noise, right? So okay, so what Python has been useful for me is in general uh, simulating stuff, analyzing the data, right? Simulation of complex systems, again, like relativistic mechanics, simulation of two heavy bodies coming close to each other. And believe it or not, when they are very close to each other, their speeds are in a fraction of the speed of light. So it becomes totally relativistic when they are very close to each other. And multi-body systems. So an example I have shown here. Right? Okay. So in this figure, you see this is Sun. The red one is Jupiter, right? And this is the path of an asteroid. So now you would think that why is asteroid taking a turn here? So this is actually a rotating frame. So Jupiter rotates around Sun, and I have just taken a rotating frame, and the asteroid is simulated in the rotating frame, right? It never gets close to the Jupiter. Okay, this is one simulation. The other simulation is this one. So what is the asteroid doing here? It started in a circle. This is not a rotating frame, by the way. It started in a circle and gradually just the ellipticity of the asteroid goes on increasing and increasing, and eventually it comes so close to the sun that it is ejected. Right? These two are simulation of the same thing, but with two different initial conditions. Right. That is one thing. Okay, so that is one thing Python or any other like programming language can be useful for. Analyzing the data is again, so you have data from a detector. This is the gravitational wave data I'm showing you, right? But you, in general, you can have, so as I said, there's observational astronomy, and observational astronomy basically you won't get these colorful images in your camera, right? They'll just be black and white images or with some filter on. So you essentially observe whatever the sky gives you, the photons, whatever is coming and hitting your camera, and then just analyze it as a time series or in a frequency as a spectrogram, right? In a black and white image, and just filter out what object you need to see using Python. But why Python? I mean, you can use C, Fortran, very well-built languages. But Python sort of makes it very easy for beginners to get into all kinds of applications, right? You want to get into astrophysics, any specific type. So I had to get into gravitational astronomy. So I found specific libraries that people had built, spent 5 years, 6 years in building those libraries, perfecting them, and which I can use readily at my um, uh, on my own, and just get the data, analyze it completely, and then get the final results. Right? And it's also open source and very easy to use. Okay. So I guess you guys already know, since this is the last lecture, right? Um So the work I have done using Python. So there are three projects I'll talk about very briefly. One is so blip glitches and LIGO detectors. So they're always, if when you have a detector, there are always going to be sounds, noises. And this is one. So these blip glitches. So you see here, this is an actual gravitational wave detection from a intermediate mass binary black hole, right? And this sort of mimics it. So if you fit in some data, fit in a model, it will mimic this kind of system. I attempted to resolve this and separate it from actual IMBHPs using the symmetry of these glitches, right? The other project I did was finding a difference between precessing and non-precessing black holes. Again, these are spinning black holes, and the trajectory that they follow depends on whether they are spinning or not spinning. And the latest one, which I'm still working on, is making a model of making a detection, what do you say, mm, detection algorithm for intermediate mass binary black holes for the LIGO detectors using Gaussian mixture model. So if you are aware of ML, then you will probably be aware of what clustering algorithms are. Gaussian mixture models is one of those, and it does not only cluster, it also sort of approximates the probability distribution of your points, of your data points. So I am attempting to model both signal and noise separately and see how I can use those to get a detection algorithm out of that. So I have been working on a bit of everything: simulation, which is simulation of a precessing and non-precessing black hole, just analyzing the data and modeling something in ML, and then using it to my own benefit in this field. Right. Okay. Thank you.
Okay, thanks a lot, Sagar, for taking out time from your busy schedule. If you guys have any questions for Sagar, you can just post it on the Slido, and you can just say, I have a question for Sagar, and you know, we'll try to get it answered, hopefully on the Slido itself. Yeah. So thanks a lot. Now moving on to web development by Dev. Dev.
Yeah. Am I audible?
Yeah, you're audible. Please go ahead.
My screen's visible, right?
Yep.
Yeah. So here I'm Dev. I'm a second year student in chemical engineering, and my interests majorly lie in machine learning and web development. So like, here's my email. You guys can contact me if you guys want to have any doubts or want to ask anything. So first of all, let's start with why everyone should learn web development. I mean, apart from making cool websites, here are some other reasons that I believe everyone should know web development. So like, let's say you're interested in machine learning, with like most people are. You will, and let's say you're working for a company. Now the data you get for the machine learning models you build as for testing is just given to you as a CSV file, right? But when you work for a company, there are a lot of other ways. Like, most of your data is in either in their databases, or it's structured in their like in their SQL databases or their MongoDB databases. So you should know how to interact with those databases, which you will know if you know web development. Another thing is most of your data could be stored in an API, and you should know how to call an API. You should know what kind of requests you should send, what kind of responses you get, and things like that. And again, that part is also very helpful for things like web scraping, which is like trying to collect data from, trying to make an automated model to get data from the internet. So that's why that is one aspect of why even people who do machine learning should learn web development, like at least should know basic web development. Another thing I feel that everyone should know web development is because, let's say you're doing research, you make some models, machine learning or not, and they're giving out great results. Now, obviously, you would publish your research, etc., and things like that. But you could also make an API, like if you don't mind, you can also make an API for the world, and they could just send the data through the API, and you could like send back your results to them. And so that is one aspect. If you're doing research, you would want to make an API. Another reason you would want to make an API is if, let's say you're working for a company, you made a machine learning model, and you want them, like, so basically making a model into a product will involve some steps like making an API. And apart from that, adding to your resume, you'll find a lot of projects in web development and app development compared to other roles. Like even machine learning you would, but like it's really easily available to get web development and app development, this thing. And once you know app and web development, you can just like make your startups into a reality, which gets point. So now, why Python? Why do you want to use Python for this? There are so many web development frameworks, right? So today I'll mainly talk about Django, which is one of my favorite like web development frameworks. Now, why would you want to use Django? It is ridiculously easy to learn. Like within a few hours, you will be able to make a decent, let's say, blog website just by looking at tutorials and understanding things. Like it would be very easy to make, and you would be able to extend it easily to other things. Like it would be very easy to implement it without like learning too much in-depth things about it. Another thing is it has a lot of features, out of which a few I demo, like an admin interface and like user authentication. The unofficial mascot of Django is a unicorn because they give features for everything, right? So it is like it has libraries and like pre-written code for almost everything. Like there are a few use cases in which Django is not the best, but for most cases, Django is the best framework. Another thing is scalability. It's really easy to scale a Django project. And so scalability is like how, if right now you have 10 users and your website is working well, if you have 10,000 users, how will it work? So with Django, it's really easy to scale it up. And yeah, so that's one of the other things. And it's really secure. It has like pre-built security options like Django, like SQL injections and things like that. It's like it has pre-built features to to stop those attacks. And like as amateur developers, we don't know much about like security and what we should do for that. So using Django makes it really easy because it's very secure. right? So these are the reasons you should learn Django over other things, and these are the reasons helped me like as a web developer. So
Dave,
like, yeah.
I hate to interrupt you, but there are two questions which I feel should be addressed right away. So
Yeah.
first question is, what is the full form of API? And the
Okay.
second question is, what exactly is Django? So,
Okay. So API stands for Application Programming Interface. And so think of it as a way to communicate with your database. Okay. Like when you type in like YouTube, like let's say you're watching YouTube, you type in YouTube and on the link it says YouTube something something something, right? Like at the top it says question mark v equal to something, right? So when you send that request to their server, it is like it's like they're sending something back to you, right? Like when you send a response, when you send a request, you're getting a response back. So the thing that is doing that for you, which is communicating between the database and you, is an API. And generally it can communicate between any two things, but to make life simpler, the thing that is between you and the database is an API. What was the other question, Arjun?
the other question was, what exactly is Django?
So Django is like a framework, and it's like a library. It's a framework which has a lot of libraries using which you can make websites. So I'll show you some example of how it works and things like that. But basically, it's like a framework to make websites. That is Django. Yeah. So it's like a framework. Uh, Arjun, was there something else?
No, you can go ahead. I guess I'll have to interrupt you
Sure, sure.
if there's something else. Yeah.
So like to install Django, you can run these commands like the one for this is for Anaconda users, and by vanilla Python I mean Python 3 if you have directly installed. And this is for Linux people, Linux and Mac. You'll probably have to write Python 3/m pip install. And so basically we'll demo a website, and these are the codes. This will be shared with you soon, so even you can run this and just demo this website yourself. So when you run this command, python manage.py run server, it will basically just run the server for you, and you can view it on localhost 8000. You can view it on this link. It would say that starting development server at blah 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 blah. Another thing, if you use other libraries, they won't tell you this, so you'd have to probably type it in or like do console.log or whatever, like print it out. So this is like a basic blog website. This is how most people start development. They start with blog websites. So you can, so these are few sample blogs that I've added. And when you click on them, you can you go and you can find the main page of that blog, like of that post. And so these are a few posts that I have added, and so you can just have a look at this website. It's a very simple website. It didn't take me much time to build. So now let's start with. So that is like basically this is the website. We'll share the link so that you can run it yourselves. And if you have any problems, let me know. Now let's review one of the cool features of Django, which is the /admin. It's like an admin panel. So you'll have to run this command. So it's probably, yeah. So you'll have to run this command, and it will ask you to enter in a username, a password, and a email address. And okay, wait just 1 second. Sorry for this. And a password, and please note the password you type won't be visible on terminal. So like you can just make a user like that. I'm not making a user right now because I've already made one. And so now when you go to your website and you just type in /admin, it will ask you to log in. I have already logged in, so it didn't ask me. And here you can see all the data you have, like all the data that you have added, like your posts and things like that. And you can edit the posts. You can add new posts, like save and add another. You can add new post, and you can just edit your posts. You can search for a post like another. So it'll show you all the posts with another in the title and things like that. So it's a pretty cool thing. Like, you don't have to write any code for this. This is inbuilt into Django. And so, like, this is an admin panel. Like, so if you just type /admin, this will show up. You'll have to log in, this will show up, and you can fiddle around with this. Again, if you have any issues, let me know. Just run this command to make a user and sign in with that user at the /admin. Yeah. And so, okay. And so that, like, just have a look at the admin panel. You would, so, like, keeping that aside, this is like the basic file structure. I won't go into much depth. You can have a look. Like, if you're interested in web development, you can have a look. But the command I write, if you see, it's Python 3 space file name, right? So manage.py, and then I'm saying run server. So that is setting up a server and running it for us. And so that is this file basically, and that's like the file that lets you interact with your website basically. That's like the main file, and settings is like the configuration file. And these are a few other files, and not all of this is pre-made when you use Django. You don't have to sit and write it on your own. Like, that is another great feature about Django. And so, like, you guys can read this. If you have any doubts, you can ask me, like, later. And so my experience with web development is this. I've worked with Django and Flask, and I've worked with a few JS library frameworks as well, like Node, React, and Angular. To beginners, I would say Django is the best, and Flask is also really good if you want to. So this is my experience. And for a closing note, like, Django is really good if you want to make something which is complicated and which has a lot of features involved in it, because you won't have to code more. And Flask is better if you want to just upload the model you have made to the internet. And these are a few basic references. You can look at these. And yeah, that's it.
Hey,
if you have any
Dave,
questions. Yeah.
one quick thing that you can go over is I mean, you can talk about what front end is, back end is, and how Django relates to both of them, maybe.
Yeah,
I
sure, I
guess.
can do that.
And one more thing, if you could answer whether people can make their own website for free.
Yeah, you can. It's
Yeah.
absolutely free to make your own website, and there are even hosting services that, like, you can put it out on the internet. Like, it's as simple as that. Like, there is this thing called Heroku. You can have a look at that. It's a free hosting service. Heroku. And Django is completely free. It's open source. And so
Actually,
basically,
Dave, maybe it's better to tell them about front end, back end, and then talk about hosting, I guess.
yeah, sure, sure, yeah. I'll just so basically, what is front end? Anything you see on your screen right now, that is front end. Basically, the HTML page that is coming up to you, in simple words, that is your front end. Now, what is your back end? Your back end is the API that you made that is interacting with the database and giving you back this HTML page. So this HTML page is the front end, and the back end is the API that you have created, which renders in this HTML page, right? So if we look into this Django project, there are quite a few files. Don't get intimidated by that. This is just to make your life simpler. Once you have a look at once you have a look at the tutorials, it'll get much simpler. So if you see in this, we are saying index.html, right? So this is Django telling you that go to this file index.html and throw this out to the person who has come, right? And basically, so that is what that is like the front end, and the back end is like this, like let's say this model, it's like a model which is stored on the database. Backend would be getting this model from the database, and so like you're getting the model here, like post.objects.filter, blah blah blah. You're getting the model and you're sending the model to index.html. It doesn't look like you're sending it to index.html here because Django makes life very simple, but basically this query set is going to index.html. So you could say this is kind of like your backend, and this HTML code and the JS code that you write is like your front end. I hope that answers that, Aryan.
I'll just add one thing, okay? So
Yeah, sure.
maybe so basically what they've meant to say is front end is the part with which the user can interact, okay? With say I'm visiting a website, say Google, okay? So what I see on Google when I open it, that is called the front end. That is what anybody using Google will be able to see, okay? And the back end, on the other hand, it is the code that the user cannot see, okay? But it is essential to the website's management, sort of, okay? And it's sort of like let's say you have some computation, okay? uh, you can't do it on the user's computer because why not? Because it's not guaranteed that the user's computer will be fast enough to do the complex computation you want to do, okay? So usually what you do is you put any computational heavy things into the backend, okay? And the backend runs on a server, right? So what really happens is when user opens the website, you are basically communicating with the backend. The backend says, this is the page that I want to show to the user, and that page comes to the user. Then the user can type in something, say, user searches something on Google. Okay. So when you click on Google search, okay, you are triggering an API, right? So what an API does is it helps the front end and the back end communicate. Okay. So when you say Google search for cute monkey pics, okay, so what happens there is cute monkey pics, the string, it goes to the backend of Google. Google does something on that. It selects a few pages from its knowledge graph. Okay, so that's what Google is doing. And right, so and then Google says this is the page I want to show. These are the images I want to show, and please serve this to the user. And then this is what comes up on my screen. What they've showed you. So that's what front end versus back end is. Okay, so not all websites need a back end. Not you don't really need a backend for all websites, mainly because well, they might not be as complex as requiring a backend, right? So
Yeah,
for
like
example, yeah, go ahead, please
yeah,
go ahead.
like imagine you have a website for like your resume. Like the content over there is not going to change. It's going to be static, right? Until you want it to change. So for those kind of websites, backend is not required. But for complex websites like Google, a backend is definitely required.
Right.
I
Thanks
think
a
yes,
lot,
like it's getting a
Nitish.
bit too technical. So basically, the point is this: if you want to differentiate between front end and back end, I'll give you a quick analogy. You go to a fine dining restaurant, you get a like a plate at your table, you interact with the food, you eat the food, you see the presentation, all of that is front end. What goes into actually making the food and serving the food to you, all the making of the food in the kitchen, getting the components from the refrigerator, all of that, that is the back end. Whatever happens in the kitchen is the back end. Whatever you eat, whatever you look at, whatever you click photos of and post it on Instagram, all of that is the front end. So this is a very simple analogy to understand the
Right,
difference between
and the
front end and
waiter
back
is
end.
the API. by the way.
Yeah, pretty much.
Okay. Thank you so much. Thank you so much, Dev. Thanks, Shivam, for the awesome analogy. Maybe we can move to Dipesh. So, Dipesh, are you here?
Yes.
Yeah,
Let me share my screen.
for sure. So, guys, you can still continue to use Slido if you have questions.
Okay, so hope it is visible. Yeah, so my name is Dipesh. I have completed my graduation in like by the 7th semester, so it's known as fast track. And in the last semester, I joined my company, like the job. Okay, so let's go with the Python in machine learning. So what is machine learning? So machine learning is basically an algorithm that allows us to become more accurate in predicting without explicitly programming. So let me clear the difference between explicitly program and what it is like a probabilistic approach to get the output. So take an example, suppose like a face detection. So after like programming explicitly, so suppose I have a database of faces, like faces with names, and to do it face recognition, I will do with the query image, I have to match each and every image with the database. So suppose like this is the database, I have a query image and some examples with the database images. So first I need to crop that face, then resize it to the images of the size of the database, and then I need to do this matching one by one, like for loop for each of the person, and then taking dot product with each of the this cropped query image. And if the dot product is greater than some threshold, then I can say that this is the match for this. Like suppose for this person, here is the database image. So when I will take a dot product with the query image, then it will be like around a zero point 0.9 or 0.95 on the scale of 0 to 1, compared to other where it will be around like zero point 0.5, maybe zero point 0.4, something like that. So this is the manual operation, and here the important manual step is to detect the face and then cropping it. So this is the thing which we have to do manually, and here we are doing this explicit programming. And now moving towards the deep learning portion or machine learning portion, where we are going to predicting it. So suppose we have a database of faces, same if here the images and the labels are corresponding to the name, and then we will choose some machine learning architecture suitable for this face detection. So normally for image processing we use like ResNet or VGG. So those are the deep learning architecture. You can easily Google ResNet or VGG to get the idea of how it is made and all those things. And then the important part is training the model. So for like how the model is getting trained, like it's a machine learning portion, and you can get like plenty of easy tutorial. I have linked some of them. So for training that model, you need data, then forward pass and backward pass. And with backward pass, you basically train the model. So I am not getting into it right now. So this is the image, and you will do this forward pass. So there are like plenty of filters which will try to detect like nose or eyes or like some mustache or beard, and like going through this like some lower level features like mustache and eyes, all those things, and some higher level features like combining all those features if it is like say person A or person B or person C. And then we have fully connected layers. So it is nothing but some non-linear combinations of these features. And if it activates some neuron like corresponding to it, then it will predict it as the person name, like say 0 to 9 corresponding to the persons, say like A, B, C, like till I. So this is the usual pipeline of deep learning like classification. So is there any doubt till this point? So this is what machine learning is, like a brief overview.
I think it was a little bit confusing for people. Maybe you can like go over it from a more basic perspective, you know, as in
Okay,
what machine learning is. It's sort of like the modeling and
okay. So it is clear
modeling
like
perspective.
without machine learning how we will do. So this is just a basic example, like very naive. like very rough approach where we have the database, then the query image, and we do this cropping of this face manually, then resizing and trying it one by one. Why I am saying it this like manually? Because we like it requires human insertion. Like maybe the image might be like this, like here, and then maybe like completely like this. So we need to get the exact face. Why? Because in our database the images are like this. So this is what the manual or explicit programming is. And in machine learning we have this like sort of architecture where we do this like input image, then applying filters. So like suppose the filter is of size 3 cross 3, then going like in a sliding window fashion, like 3 cross 3, then getting something. So these are the arrays of features, like matrices, and then again going like applying more features in the layer 2 on the output of the features, or filters of layer 1, and so on. So this is the deep learning framework and the forward pass portion. And at the backward pass, suppose it is like the wrong output, like the output is suppose this is like person A and the output is say person B. So then using this back propagation, we back propagate the loss and change the weight so that this model can classify this person accurately. So in all those cases we have uh, control over the filter size and the number of layer, all those things, but we don't have control over what these features might be. So for typical deep learning model, these are the like output after applying like few layers of like filters, like after layer 1 or layer 2. So it looks like this. So we don't have any control on how it is learning, like what it is learning basically. So this is a deep learning architecture. Most of the time we also call it as like black box model, because we don't know what it is going on in here, like the weights and matrices files. So that's the machine learning part. And then the another question is like, why Python for ML? Like there are many languages like C++ and C, Java, etc. So why Python basically? So as you all know, it is like concise and readable, very user friendly and intuitive than other programming languages. Also, lot of well documented frameworks are there in the Python. Like for machine learning, we mostly use TensorFlow, PyTorch, Keras. Um, Also, there are other libraries as like pandas and numpys for handling data, like like data science, big data. So all those things comes into this picture. Like we use pandas as a tool to understand data, make different graphs, all those things. Also, there's like the community is quite large, so that's why the documentation is proper, and the like like question answering and all those things. Also, there are other languages like R, Scala, Julia for this, but not as well developed as Python. And also, like what are like PyTorch and TensorFlow? So they are the frameworks which like wraps background processing into the APIs. Also, it supports CUDA. So if you don't know what CUDA is, like when we play games on our computer, so it is a graphics card which accelerates the rendering of graphics. So in this case, in a machine learning, we need matrix multiplication, and the same GPU or say graphics card is used to get this quickly. So it is like multi-threading, so multiple cores of CPU targeting one and only task, which is matrix multiplication. So that is what GPUs, and CUDA is basically intermediary language which enables Python to use multi-thread of GPUs. So that is CUDA. So in PyTorch and TensorFlow, it is like inbuilt and in fact properly working and like that. Also, the forward propagation and back propagation models are already there in PyTorch. So if you try to write this machine learning training program in one Python file, then it is like loading the data, then pre-processing it, again making an architecture, going forward pass, backward pass. So all those things are hectic. But in API, like you can do it just in few lines, like 3 and 4 lines, and you are done with one complete deep learning model training. like classification or face detection, whatever it is. So that's what like PyTorch and TensorFlows are. So let's come to the research in machine learning. So like as we all know, the deep learning is used in like autonomous navigation systems, medicine and health, generative modeling, or robotics, etc. But without knowing what it is there in the black box, it is not say advisable to use it. Like suppose if our model is predicting that the patient has cancer, so we would like to know that looking at which tissues or cells or in general cues the model is saying that the person is affected by cancer or is having cancer. So this visualization or checking what model is learning is known as explainable AI. Like we need to know and the explanation from the model, looking at which it is deciding it predictions. So there are a few work going on. I have also done some research on that. So suppose this is the example, like a person with a like riding on a horse. So we have like two robots, scenario A and B, where like robot A predicts it is a person, and robot B also predicts it is a person. So after asking like looking at which features it is saying as person, so robot A highlights this portion, like this one, and robot B highlights the portion where the head is there and the hands and the torso. So which robot is more reasonable? So when robot is properly able to see the person, like in robot B, so we can say that the robot B is more reasonable than robot A. So that's what the understanding the model's decision is. So there are few methods to decipher the model's decision, like GradCam. The one which I showed you is GradCam. So like GradCam, this one, like I have authored this paper, co-authored basically. So it is like checking the exact fingerprints of the learning procedure. So that's what it captures. Then there are also other visualization methods like maximizing the output, etc. So I am going to show you a quick demo of GradCam. So you can just like okay,
Dipesh,
yes.
actually, it might be too difficult to accommodate the demo. In the interest of time, maybe you can add a slide on how to use the Colab notebook, and we'll provide them with the slides anyway. So, is that fine? Would that
Okay,
be?
or maybe I will just like show what is that notebook is about and just like how we can just play around it. So it's not
Sure,
like,
sure,
yeah.
sure.
So let me just do that in a minute. So okay, so I have like given all the references. So it's like in interactive GradCam. Okay, so there are like two data sets like ImageNet and Coco. So those are two different data sets. So let's go with the ImageNet. So here is the Colab notebook corresponding to it, and just run it. So it basically calls the like model, downloads the weights from my GitHub account, also the some sample images, and then run it. So like you can directly go to the last cell to check like show GradCam. So I have uploaded my own image like author, and the target class is none. So I just want to check like what model is searching for. So if you are able to, okay, so if you are able to see this, so it is like a ResNet 50, one of the many architectures like ResNet VGG, and it is targeting it as a lab coat. So it's sort of like I am wearing a lab coat. So in ImageNet, there isn't any class like person, or else it would have classified it as a person, but the close one is lab coat. So let's go with, so I am like here in my pocket, it's like a ball pen, and it's a class in ImageNet. So let's comment this like ball pen, and let's go with it. So you can see here the focus is like on the entire image. Most like like the reason most highlighted is like the complete shot, But when we are targeting the ballpoint pen, so it is mostly nearby, like the ball near the pen basically. So we can say that the model is properly able to see the ballpoint pen, the lab coat distinctively. So we can again like try folding chair. So in this image, like in the background, at the end a chair is there, and a folding chair is the class in image. So class means it's like in the database there is an image of chair named as folding chair, and the ID is 559. So you can see again like it is shifting to this folding chair, like from shirt or say this pen, it has shifted to the chair. So from this we can decipher what our model has learned, like the black box model basically. So you can like try uploading an image, say okay, so like an image of me in yearbook which I have posted. So you can see that the image is uploaded here, and we can like I have already written, so just like yearbook. So you can just uncomment it and just run this cell. So running this cell is like from clicking here. Okay, so like it's highlighting some area. So you can play around it. You can upload any image and try like what it is looking for and what it is checking. So yeah, that's it from my side.
Thank you, Davesh. Thanks a lot. Let's move to Ajinkya. We'll cover quantum computing and how Python is used in it. Ajinkya,
Hi. Yeah,
hey,
I'll just share my screen.
sure.
Yeah, is my pointer and my screen visible?
Yeah, it's visible.
Uh, Hi guys, I'm Ajinkya. I'm a fourth year undergraduate in engineering physics. I am a dual degree student, so I'll be going into my fifth year now. I work on a lot of aspects of quantum technology, so I'll be taking a very broad stroke approach in talking about quantum tech. Where does Python come in? What have I explored? And then just what have I used Python for myself? So those are the four basic points I'll try to cover today. This, by the way, is a very great comic by SMBC, which I highly recommend. These are just the four initial panels, but the entire comic is very good. Right. So let me just quickly remind you what is quantum. I won't go into the physics of it in the interest of time. The basic point that I want you to take home is that it is more fundamental than the classical physics that we are all used to, that we use in our computers, etc. And yeah, quantum mechanics is weird. There is the uncertainty principle, particle wave duality, wave function, all of these concepts that you're already familiar with from PH 107. Um, and there is something called measurement which collapses the wave function. What if you're not comfortable with what this means? We can have a discussion on this later on, but in the interest of time, I will not go into any technicalities in this talk. Right? So the point is that nature computes using quantum mechanics. So any technology, the basic viewpoint in the field is that any technology can be improved using quantum mechanics because it's fundamentally different and it's fundamentally more realistic, so to speak. Now, there are a lot of concepts that you have been introduced to in PH 107. After doing MA 106 linear algebra, I would say that it would make quantum mechanics a lot more accessible. But if I want you to have two things in mind, it is superposition, which is basically a complex linear combination. The best example of this is obviously Schrodinger's cat, which you might have heard of. The cat is, but I will again not go into what a superposition really means, but I will just warn you that the system being in a superposition is not the same as the cat is being both alive and dead. But for the time being, having said that, I'll still like we'll just assume that okay, this is the picture of a superposition, and that's fine because we'll not get into the technicalities. Probabilities come fundamental with the theory, which means that any random number generator will that we use on our computers are not really random. They're just the function are just very just have a lot of fluctuations. But probabilities from quantum mechanics are fundamental, and therefore the random number generators that you get from these are, are perfect, so to speak. Yeah, measurement is a hindrance. Qubit is a quantum bit, which is to say that instead of having zeros and one, you can now have superpositions. These qubits can entangle with each other, which means that you cannot talk about a single qubit if you have entanglement. And because measurement changes the system, so you can't clone the system because you will never know what the actual system is. If you knew the actual system, then the system is changed. So um, you cannot clone a system, which is another big issue in the field. Having given a very bad description of what quantum mechanics is, I will now proceed to the more interesting part of the talk, which is to motivate you to explore this field regardless. So the point here is that quantum mechanics underlies everything that we are doing. And there are a lot of field where a lot of stride has been made in introducing quantum mechanics and then showing where do factorization much faster than any classical computer would. You have new complexity classes which come in when you take into account quantum algorithms and quantum computers. You have quantum gates and quantum transistors which perform much better than existing logical gates. And like everything else, there is an information theory which is based on quantum mechanics. There's quantum control theory. So there is controls which you have from Syscon, which are classical controls which you apply to quantum systems, and there is also quantum control, which is using quantum mechanics as a tool to control any system, which is also better than classical control, and so on and so forth. The point I'm trying to make is quantum mechanics is everywhere. It is in all these fields which are being explored by 80% of ITB students, and you can just add the word quantum in front of it, and it adds excellent new dimension. The map of quantum physics gives a very good perspective of the field, and it's around 10-15 minutes, so I would recommend you watch it. Yeah. So even if that is not enough to convince you, this is a list of fields which are under active research, not just in academia, but also in the industry. The best example I have is airplane design. You must have heard of Airbus, which is a big leader in the aeroplane industry, and it has recently introduced a competition which basically asks for quantum computing solutions to existing aeroplane aeroplane design problems. Right. There is optimization is constantly being improved using quantum computing. You have machine learning, not just existing machine learning, which is used on quantum computers, but also quantum machine learning, which is a separate field, which is basically using similar learning techniques on quantum machines. So the broad point I'm trying to raise is, if you're interested in any of these fields, there is an argument to be made that you will be interested in the quantum analog of these fields as well, and they are very, very interesting. Now, where does Python fit in? Python is basically an excellent language for someone like me not uh, who's not into computer science and not into coding, but really wants to make use of good scientific and computational tools to make my processing faster. In this day and age, I don't know of anyone who does research completely on pen and paper. Everyone needs some or the other kind of code, and Python is one of the best languages out there. It has basically overtaken MATLAB in many domains as the primary choice for for any physics field. In fact, not just I'm talking about quantum tech, but in general, it's used in a lot of places. Qtip is an excellent package which I've been using for more than 2.5 years now, and it's easy to pick up. It has great tutorials. In fact, many of the theories that I learned, especially in terms of how to code it in Python, have come directly from Qtip tutorials. And I would recommend that you just go on, even if you're not familiar with quantum mechanics, the way they explain it is very good. So I would recommend that you just go to their website and just pick up that any of the tutorials that you like. And it's very easy to integrate machine learning tools and optimizations and parallelization. All these tools that exist. Especially, I have found that they're very difficult to integrate in C++, but in Python, it took me less than 2 hours to learn parallelization. I'm not a machine learning expert, but I was able to integrate it for optimization in specific scenarios very easily using Qtip and Python. Sorry, it is a silly typo here. But anyway, there are many more packages in Python these days. QSpin is a package for quantum dynamics. It's so for people who are very, very specialized in some narrow condensed matter stuff, will not bother about it. NumPy and Matplotlib, I guess you're all familiar with these by now. SymPy is basically symbolic manipulations, very useful when you basically want to use numerical calculus for in terms of variables and then just insert the variable at the end. This is slightly different from what functions do, because in terms of in symbolic manipulation, what you do is you basically give it an R to run the entire thing in terms of the variable, and what this will ensure is that you don't need to run a specific function again and again, which might take time. But if you do it in terms of symbols, it's way more powerful, especially for integration and yeah, especially for integration. Yeah, AstroPy, I think is something that you already saw Sagar use. BioPython and Cython are more packages which are not slightly more directly related to what I do, but they're also very common. Um, I would say that Python and basically the ease of using Python and the fact that it's very fast means that we have shifted a lot from MATLAB. Having said that, Julia is another language which is up and coming. It's slightly faster than Python in a lot of respects, but the support and the documentation that exists in Python is unparalleled and therefore still a #1 choice in most aspects. There are a lot more fields like nonlinear dynamics, computational dynamics, which I mean, by the name, you can guess that it's very, very coding intensive, and these fields heavily use Python themselves. Right. So coming to what I have explored basically a lot of things which have the word quantum in front of them. Quantum gate design is basically the design of logic gates, which is slightly more complicated than your normal existing silicon logic gates, and they are usually based on lasers or they're at the atomic scale. So there's no way for you to analytically understand how they work other than doing numerical simulations. So I have been doing that a lot myself. There are heat engines and batteries which incorporate quantum mechanics, and this is up and coming field of quantum thermodynamics. So this is from my BTP, which will in preparation right now. And what I did in my BTP was I took quantum batteries, which you can just which are basically just some more fancy way of talking about batteries. I took optimization, which is basically control theory, which has a very good support on Python, and I combined the two. I applied control algorithms on these batteries, and I've formed optimal batteries. You don't need to worry about what phase transitions are doing here. But the point I'm trying to make here is my life became much easier because I did all this on Python. I mean, this entire thing comes down to less than 100 lines, which is very few in the kind of work that I do, because if you go on MATLAB, it will take maybe 200, 300 lines of manipulations. So Python is much simpler. Yeah, so there is control, and then there are foundations, metrology, estimations. We'll not get into this. I might talk about what NISC here stands for if I have the time. We'll see. Right. So, like I said, where have I used Python in all this? I have used Python everywhere. In all of these projects, I have run Python. I have not used pen and paper that much, even though I do work in theory. I do not work with experiments, and yet I have found myself doing everything on Python. I solve Schrodinger equations for any kind of potential. As you might know from PH 107, there are very few potentials that you can actually solve the Schrodinger equation analytically for. So Python and Qtip has a very good support system for solving Schrodinger equations in general scenarios. You can run optimizations, and Python again has very good support for optimization and specific optimization algorithms which exist out there. You can write your own code, and Qtip allows you basically to take the source code, tweak it according to your needs, and then use that. So that's a very good support structure that exists. Yeah. So I have created heat maps, approximations. I have tested work done, efficiency of heat engines, quantum batteries. All of this I've done numerically, and all of this I've done on Python. I've recently moved to Julia for some very, very specific things, and I have realized how much difference it makes to have a good support structure behind the language, because Julia does not have very good quantum support, which means I have to write every single thing by hand, which is a huge pain. Anyway, these are some plots from my projects. These are just, they were just pretty, so I plotted them. Here you can basically see that there is some energy which increases with some factor gamma. And the point here the reason I have it here is I tried doing this on MATLAB, and Mathematica, which basically took me around 8 to 10 hours. And Python, this took me 3 hours and 10 lines of code. Most of these are similar. This is actually an optimization algorithm, which again I could fit in less than 50 lines. And the sinusoidal wave is the initial pulse. And after applying some optimization, I get this new pulse. And Python has very good optimization support, which you can see on QTip's webpage. Right. I'll not bother into these plots. These are just pretty, so I put them here. Right. So there are a lot of resources which exist. Most of these are articles or YouTube videos which will take you less than 10 minutes to read, and these I just put them here because I found them very informative and factually and technically sound. So especially, this Richard Feynman's lectures, very nice to read, because and quantum computing in the NISQ era is a very good for anyone who likes the field but does not want to go into it because they don't want to end up in academia, because it gives a very good idea of where the field is headed in terms of industry, especially sensing and instrumentation and software. So yeah, there are a lot of resources for you to get started. You'll see the word MNP a lot. I wonder why, but anyway, the one thing I would suggest all of you to go through is this quantum computing article by Princeton University, which came out in 2018. It gives a very good perspective of where the field is today and where it can be in the next 5 to 10 years, which is when you will enter the field yourself. So yeah, I will. Okay. Aryan, do I have some time to go to the bonus slides, or maybe I'll just skip and
Maybe you can do one or two.
Okay. Okay. Let me just take a minute, because this is basically, by the way, this is a quantum freeze. The only reason this picture is here is because every time you Google quantum computing, this is the first figure comes up. All this figure it's a fridge. There are very, very small qubits sitting inside, and all this big gold fancy instrument is doing is cooling it down. This is not a quantum computer. This is the only reason I put this figure in here. And by the way, this is the last few panels of the SMBC comic that I cited in the first slide. So yeah, anyway, I just wanted to take a minute to underline 2 points. The first is quantum computing does not solve problems by parallelizing everything, which is a very big misnomer. Basically, what it says is, what people believe is, okay, you have you have what is called, you have a qubit, so that means I can try 0 and 1 together, which means I can try everything, all combinations of bits, strings together, and then I just run everything together, and that's why there is speed up, which is not the case. And in fact, there's a very good chance that running everything together will not give you any good result at all. Entanglement plays a very big role. And yeah, I just wanted to underline that one point. The second point is quantum teleportation sounds fancy. It's not what it sounds like. It's not. It's just something that comes out of the statistics of the math. You just do the math and you get the statistics, which seems to suggest that information travels greater than the speed of light, which is not what happens. You still need someone to pick up the phone and talk to the person on the other line. Otherwise, there's no point to teleportation. Um, Quantum simulations is a very big and upcoming field these days, which is why I have put this quote by Richard Feynman, which is essentially the 1982 lecture which kickstarted the entire field of quantum technology, which came basically from the need to simulate quantum mechanics, which is to say, trying to simulate nature. Right. These are a couple of roadmaps. The word NISC has appeared a few times. It basically stands for Noisy Intermediate Scale Quantum Technologies. What does that mean? There is too much noise in these days in your average computers which rely on silicon devices. There is a lot of noise, but your technologies these days are robust enough to not bother about them, which is why you don't care that much about noise. But quantum technologies have not reached the level where you can ignore the noise at room temperature, which means you need the fancy fridges and you need fancy equipment which isolates it from outside too much. So what NISC stands for is basically algorithms and optimizations and machine learning tools which are optimized for machines which we can make today, which means these machines will be noisy. They will not be full scale like your laptops today. They'll be maybe like 50 qubits or something. And what can we do inside that is NISC. And there is a lot of funding which has been put recently. I think 2 years ago, the Indian government gave $1 pumped $1 million into this field 2 years ago, and this is on top of $30 million which came in 2015, and that's just the Indian government. I mean, there's a lot more money which has been put into quantum tech outside India. This is IBM Quantum, which is one of the industry leaders, and this is their projections. You can see right now you have around 27 and 65 qubits which they are able to use fairly well, and their aim is to reach a million qubits in 2024 to 2026, and therefore it's a very good time to be alive. That's about it. If there are any questions, then maybe I can answer them. Otherwise,
Ajinkya, we'll take
that's it
the questions
from my side.
offline. We've given them a link where they can ask questions, and we can just relay the questions to you. Okay.
Okay. Yeah.
Okay. Thanks a lot, Ajinkya. It was a really insightful talk with a lot of truths. So, guys, I am back. So I'll quickly, you can consider me the fifth speaker. I'll quickly go over machine learning from the very basics in like 5 minutes, and then we'll try to end this. Okay. So what is machine learning? It's a sort of glamorous modeling. Okay. It's nothing more than that. Okay. So what you do with that is you have some model. Okay, which has some task. Now I'm not going, I'll go into it. Give me 2 minutes for that. Okay, which models some task. Okay, and it uses mathematical computation to, you know, sort of, I mean, there is some mathematical model that sits there. Okay, that is machine learning, just modeling. Okay, now now how is machine learning useful? Let's say I'll just take the example that Dipesh took. Suppose you want to find a face match. Okay, you want to recognize somebody's face, right? So images of one person can look quite different, uh, but they have some basic features, right? They have, say, similar hair, or they have similar eyes, or similar other facial features, whatever you want to pick. Okay, so what really happens is machine learning uh, is is a method sort of that allows, well, a model to learn on its by using examples. Okay, right. So instead of writing normal programs that you're used to writing in Python, for example with if else or whatever, okay, machine learning automatically models whatever it wants to. Okay, using some technique which I'll talk about, but it just automatically models something, and it is able to learn through examples. Okay, so I'll give you an example. I mean, I'll give you an instance of who learns by example. I think the best instance of who learns by example is human beings, right? When we are like babies, we learn by example. Okay, we learn about say laws of physics by example, sort of, right? So that's basically what machine learning is. Now, maybe I guess there are a lot of models in machine learning, starting from say logistic regression. Okay, uh, I don't know what else is there. Linear regression is one kind of machine learning model, by the way. I mean, it's you can technically call it a machine learning model, and there are many such models. Okay, so there is this thing called backpropagation. Okay, it's an algorithm that allows to learn by example. Okay, now the exact idea of backpropagation and everything, I will not give it to you, but it basically it uses math, calculus to learn. Okay, now obviously how it is useful machine learning is recognizing somebody's face using if else uh, conditions is really difficult, right? I mean, imagine that you have somebody's picture and you want to say this thing is I mean, this is Shubham. Okay, this is Shubham. That you and I mean you have some picture of Shubham and you want to identify it as this is a picture of Shubham. Okay, you want your computer to identify it like that. Now, if you write if else and you try to find features in the photograph. What do I mean by features? You try to find things in the photograph that are specific to Shubham. Now, that is really difficult. Okay, so instead we just use machine learning for it. Okay, now going really into depth of this and everything, uh, I will not do it. Rather, you should do it using lectures. Okay, there is a course by Stanford on machine learning. Shubham, are you here? Maybe you can tell them some courses on machine learning.
Yeah, you can just do Andrew
Shubham,
NG
are you
course from
available?
fall to. Yeah, you can hear me, right?
No. Is there anybody in machine learning available? Yeah, yeah, okay. Shubham, you can tell
Andrew
them some
NG, I think.
courses
I
where.
think that's what Shubham is trying to say. Andrew NG,
Yeah, yeah. Andrew
Stanford.
NG is
Yeah,
Stanford CS229 from fall, or you can just do his Coursera course. Like his actual course from Stanford is a bit better, but you can just do the course on Coursera. That is also pretty good. But the only drawback is the exercises there are in MATLAB. But you can easily search the exercises of the same course for Python, and you'll find a lot of GitHub repositories having the exact same assignments in Python. So that is the best course to begin with. And then after that, you can keep exploring the various subfields of ML as you like based on your interest. Maybe you can
correct.
explore computer vision or natural language processing or reinforcement learning, anything that you like. But just start with a basic course to get a
Right.
basic idea of the whole field.
Thanks for reminding me. I mean, there are a few areas where machine learning is applied, like computer vision, that works on images and videos and stuff like that. Then there is natural language processing that identifies that, like, about conversation, how to, I mean, it's about understanding text. Okay, it can be about chatbots and everything are based on NLP. Okay, then there is reinforcement learning that basically it it learns by trial and error. Okay, so all of this is possible using machine learning. you know Things are, I mean, there are a lot of things to be done with machine learning. More on that online, please google it out. Start with the Andrew Ang course. I've typed this guy's name. Okay, I personally like the YouTube course, the official Stanford course, more than the Coursera one. But the Coursera one is really basic and everybody will understand it. So if you're not comfortable with math very much, so you can just start with that. Okay. Now,
Just to add
okay.
1 second before like you finish and before we finish
Yeah,
this
yeah.
topic.
Go on, go on.
Yeah. So there are a lot of apart from options online, especially if you're a UG, there is this data science minor as well. So while you're doing all this stuff on your own, you can certainly explore all these things in the institute as well, parallelly. So yeah, there are a lot of
Exactly.
course options that you can take up in basic as well as advanced ML. So that's a whole new area. So if you want any specific suggestions, I think you can ping most of us here, and we should be able to help you.
You can just post it on the doubts channel, right? It's not a
Perfect. Yeah,
problem.
that's even
Yeah,
better. Yeah.
just post it on the doubts channel. Almost everybody here has some idea of these things. Okay. Now,
Also, if you are too
yeah.
excited and can't wait to get started, there is a course next semester. Like especially freshies, you are eligible to sign up for this course. Has no prerequisites. GNR 652. It is a very basic machine learning course. But if you can wait, then in the next to next semester, you will have a lot more options from like the CS department and the elect department.
Yeah, you should wait. I mean, waiting is better. I don't know why I said that. Anyway, okay. So that uh, that is how much we wanted to cover in today's lecture. Now, I'd like to request each and every member of the PyCK team to
Can we do the
show
quiz
their
first?
faces. We'll do it after the after this part. We can just do the quiz right after.
Wait, okay.
So I'd like to invite every PyCK member to, show their faces. Uh, the team, Shubham, Aditya, if you guys, hey, that's Shubham, Aditya. I guess that's Ishan. That's Aditya. We are missing Vedant today because he's facing he's battling a power cut. Let's call it that. Uh, I'm not sure if there is anybody else. Okay. Yeah. So, guys, what we did here was what seniors at IITB keep doing. Okay. We're just trying to be a cog in your learning. We want to help you learn, and you know, just look at us as, I guess, friends, lesser as teachers. I hope you guys. I wish you guys were more interactive that way. That's the that's the whole point behind this course, right? Why do students take courses? This is why they take courses, so that the professor student kind of interaction doesn't happen. It's more of a student student interaction. It's like asking a friend outs. Okay, so that's why we did this course, right? And personally, I absolutely loved entertaining your doubts and being entertained by your doubts, for sure. Okay, that was me. Shubham, would you like to say something, or Aditya, would you like to say something?
Yeah, so like the experience of taking this course with such a high number of resistance was definitely good. Like I really enjoy coding in Python. Like even in my free time, I will answer random Stack Overflow or like doubts on Stack Overflow for Python. So just like to have an opportunity to sort of get everyone into Python like in my free time on summer was basically a very good experience, and I would like highly recommend that you guys stick with it, do a lot of cool projects, because based on whatever you have learned till now in this course, you have actually learned a lot. If you have just followed the course or even just the notes you have posted, you have learned a lot. So there are a lot of really cool projects that you can do. If you ever feel like project का idea नहीं आ रहा है मुझे, so that's not an issue. You can just Google. Even in Google, if you just Google projects to do in Python, you might get a really lot of blogs, lot of lists. Maybe it's hard to figure out from there. So instead of that, just add Reddit on your Google query. So you will get links to some nice Reddit discussions. And the cool fact about Reddit is these are community discussions. So whoever has the best answers or whoever most people agree with, experienced people, those comments will be upvoted. Okay. So whenever you want to try anything new or if you want like recommendations or something like that, you can find them on places like Reddit or other forums like Stack Overflow for doubts. So just figure out what forums exist for what purpose and start using them. So those will basically sort of boost your learning process a lot. Okay, so yeah, that's all I had to say. And also feel free to contact me if you ever like want to talk about what I do, what sort of projects that I have done, what was my journey, or if you just have any doubts in general. Okay. Yeah, thanks.
Thanks a lot, Shubham. Aditya?
In addition to all these things mentioned, I would just like to say that I got to learn quite a bit by preparing the course content. A lot of things that I didn't consciously know. Yeah, I kind of, while preparing the content, I got to learn as well. So yeah, it was fun for me. apart from everything else that these guys have said already. Yep. Happy to be here. That's all.
Okay. Thanks a lot, Aditya. Thanks a lot, Shubham. We are a team of 20 odd students. A lot of us are not here today, unfortunately. But people are busy, but they're always willing to help out. Okay, so that's the one golden thumb rule of IITB, right? Okay. So enough getting sentimental. I guess we can get down to what you guys are really here for. That is the safe quiz. So, Shivam, can you run the safe quiz? Oh, you're not audible.
Yeah, hi. So I have run the safe quiz, and you can see the password in your chat box now. I'll also add it as text.
We really, really want you to fill the quiz answers properly. That helps us take more feedback and maybe improve the course for next year. Who knows? Saksham, we'll talk about that in a minute, I guess. Okay, so I'll just stop the recording.